yesterday we finished working on this example 3, and we didn't finish the entire problem. So I'm going to take you through it again and complete it. So the question reads, in the diagram, side AB or segment AB measures 5, segment BD measures 2, segment DC measures 4, and segment CA measures 7. So for that big triangle ABC that we have, that gives us the side scenario. And our goal right now is to find that red segment inside the triangle that measures AD. In order to do this, some of you had mentioned you might want to find the big angle A up here. And you can use the law of cosines to find angle A, but that's not really going to help you find that missing side length or segment AD there. And that's because you don't know if that red segment here actually bisects angle A or not. You have no idea what those two smaller acute angles are. So I would caution against finding angle A, and the recommendation from you guys was to find either angle B or angle C. So we'll start with angle B, and we're going to use the big triangle ABC to find angle B with the law of cosine. So that's going to give us down here, B squared equals A squared plus C squared minus 2AC cosine of B. And when you set this up, remember that the side opposite of angle B is 7. And then the side opposite of angle A is actually 6 total. That's the whole side length there. So when we set this law of cosines formula up and populate the values into the relationship there, we have 7 squared equals 6 squared plus 5 squared minus 2 times 6 times 5 cosine angle B. Again, take your time as you work through this. The mistakes show up that are, order of operation or algebraic mistakes. So we get down to isolating cosine of angle B here, and we divide by both sides by -60. I believe in the example we did, we may have solved for a different angle instead of angle B. I can't quite remember. But here we have cosine of B is equal to 12/60. You can simplify 12/60 or leave it as is. To isolate B from cosine B, we take the inverse cosine of both sides, and we end up with approximately 78.5 degrees. That gives us angle B. So here's the diagram again. And now we have angle B at 78.5 degrees, and we're still looking for this missing side length AD right now. So now we're going to kind of transition from the big triangle into one of the smaller acute triangles here. One of the smaller triangles, not necessarily acute. So I'm going to work with the left one. I traced it over here for us and label the sides. So again, we have a side angle side scenario. That's a safe scenario for the law of cosines. So we're going to use the law of cosines with that information to find that side length AD. And when I set this up, instead of using A, B, and C as my side lengths, I'm going to just refer to them as segment lengths. And that's because this is coming from a larger diagram. And I don't want to confuse anybody with using side length B, because side length B in the big diagram is 7. And down here on this diagram over here, segment AD there is technically side length B based on the way I labeled this smaller triangle. Anyway, we're looking for AD. We have the angle opposite of AD, which is angle B. And I'm going to populate this into the law of cosines again. And when I do so, I end up with AD squared, so that's that red side length, is equal to 29 minus 20 cosine of 78.5 degrees. I entered this whole thing in my calculator as is to evaluate it, and I ended up with 25.0126 there. And lastly, I have to take the square root of both sides to isolate or to remove the square from AD squared there. So that's what is happening right here. Don't worry about plus or minus. Just take the principal root. That's the positive because this is side length. And that rounds to about 5.0 units right now. And that was our goal, is to find side length AD there. So AD measures about 5.0 units. Alternatively, instead of using that smaller triangle on the left, we could have started the problem and found angle C here and then worked with the right triangle. Doesn't really matter. You should get the same values either way.